Welcome back. In this video, we will continue to learn about organic chemistry, and specifically we'll learn how to identify constitutional isomers. So earlier we took a look at different classes of hydrocarbons. We took a look at alkanes, alkenes, alkynes, and aromatic hydrocarbons. Now, any of those can be what we call straight-chained or branched. And if you take any given straight-chain hydrocarbon and you take some of the portions of it and rearrange it, it has the same molecular formula, but it's been rearranged into a different structure. We call those constitutional isomers. And these are molecules, again, which have the same molecular formula, but whose atoms are bonded into different locations. And these molecules behave differently. They have different properties from each other. Let's get some practice trying to identify molecules with constitutional isomers. So we have a molecule of butane, and the N is just indicating that it's the straight chain version. So if we were to take one of the groups from N-butane, take one of the end carbons here, we could attach it onto a different carbon. And when we go throughout this process, it can be helpful to number the different carbons. So here we have carbon 1, 2, 3, and 4. Essentially what we've done is we've taken carbon 4, we've reattached it here to carbon 2. We now have a constitutional isomer. This is called isobutane. For N-pentane, let's go ahead and number these. 1, 2, 3, 4, 5. If we now take one of the N's, take carbon number 5, we can place it here. We get isopentane. We can get a different constitutional isomer here as well. We could also get neopentane. So if we take that isopentane, we take one of those carbons and we now move it here to this position. We now have 1, 2, 3, and then carbon number 4 and 5. So you can see this is again a different arrangement of a molecule with the same molecular formula. Now we look at N-hexane, and we could repeat this process. Label the different carbons, take one from the end, and attach it throughout. And so what you can see here is that as we get larger and larger molecules, we get more and more possibilities for our constitutional isomers. And so it's important not that you memorize these different constitutional isomers, but rather that you recognize that these molecules are related to each other as isomers. All right, so let's practice here. Which of the molecules below are constitutional isomers? Pause the video and see if you can solve this one on your own. Okay, so what is a constitutional isomer? A constitutional isomer is a molecule, two molecules or more that have the same molecular formula, but different arrangements of atoms. So the first step in this process is to identify the molecular formula for each molecule. Keeping in mind, each point and each vertex represents a carbon, each end and vertex represents a carbon atom, and that there are hydrogens attached such that carbon ends up with 4 bonds. So this is C5H10. It's 1, 2, 3, 4, 5 carbons. There's 2 hydrogens here. There's 3 hydrogens there, 3 hydrogens there, and 2 there. C5H10. This molecule is C5H12. You can see it has the same basic pattern, but now we don't have that double bond. Molecule number 3 is C5H10. Molecule number 4, C5H8. And molecule number 5 is C5H10. We'll get more into depth on this later, but hopefully you notice something here. Molecule 1 and molecule 3, they both have 5 carbons in them, and they both have a double bond. It turns out that that, in and of itself, is enough information to tell you that they're geometric isomers. It's a little bit harder to tell, but number 5 is, or excuse me, that those are constitutional isomers. It's harder to tell that 5 is directly related to molecules 1 and 3 as well, but it turns out that forming a ring in an organic molecule has the same effect as making a double bond. And so molecules 1, 3, and 5 all have the same molecular formula, but different arrangements of their atoms. Therefore, they are constitutional isomers. So that means our answer is choice C. That's it for this video. Thanks very much for watching. Have a great day.